You may have seen or heard about satellites falling out of the sky, but how exactly does this happen? Satellites are placed into orbits at a specific altitude and speed, so they keep falling towards the Earth, but also moving forward at the same time, which balances out the gravitational pull and keeps them in a stable orbit. Essentially, they're in a state of continuous freefall. When a satellite's altitude decreases, atmospheric drag can slow it down, causing it to fall towards the Earth and re-enter the atmosphere. This is called re-entry. In some cases, satellites can also fail due to technical malfunctions or collide with other objects in space, causing them to fall out of orbit. But these all seem too elementary to be unavoidable, and surely aerospace engineers are able to account for these impedances. So, what's the real cause of satellites falling out of the sky? Are there some things which are beyond our control? Satellites are of course orbiting the Earth in space, a region where the local pressure is zero, or a vacuum. But this is not entirely true. The density of the Earth's atmosphere generally decreases exponentially with altitude, so this means that even where the International Space Station orbits the Earth, the drag is really small, but still significant in a large period of time. Eventually, drag causes the orbital speed of the satellite to decrease, causing it to lose altitude. For example, the International Space Station usually orbits about 400 kilometers above the Earth's surface. But the effects of atmospheric drag can cause the station to lose as much as 100 meters a day in altitude. Therefore, regular reboosts are required, usually about once a month. Otherwise, the ISS will lose altitude very quickly and burn up in the atmosphere. This effect can clearly be seen on a graph, noting the times of reboost and loss in altitude. So yes, the atmosphere causes satellites to move out of orbit, but it's not the only thing that causes orbital perturbations. During its 11-year cycle, the Sun transitions from what is known as solar maximums and solar minimums. Although the intensity of these peaks are difficult to predict, being able to foresee the timings of these solar maximums is what could save a satellite. During a solar maximum, the Sun changes the space environment of an orbiting spacecraft. In addition to polarity changes, which can damage sensitive electronics in satellites, the increased solar emission also causes Earth's atmosphere to sort of puff out, creating increased drag on orbiting satellites, and making their orbits decay more rapidly than predicted. If solar maximums are not accounted for, satellite orbits would easily deviate from their original orbit, and eventually fall back down to Earth. In fact, the infamous event of the Starlings falling out of orbit was caused exactly by the solar phenomena. Long ago, people thought the Earth was flat. Many believed that you could sail to the edge of Earth and fall off. We have long since dismissed this idea, as we now know the Earth is a sphere, right? Actually, the Earth really isn't a sphere. It's an oblate spheroid. Because of the rotation of the Earth on its axis, centrifugal force bulges the equator. In fact, the radius at the equator is about 21 kilometers larger than the radius at the poles. This unevenness in the geometry of the Earth causes what is known as J2 perturbations. Imagine a satellite orbiting a perfectly uniform and spherical Earth. Notice that as it passes through the plane of the equator, its orbit remains unchanged. However, in essence, the Earth bulges out more in the equator than in the poles, and so there is a larger mass concentration near the plane of the equator. What this means is that as satellites traverse through the equatorial line, their orbit actually deviates a very slight amount due to the greater gravitational pull, but eventually, through many orbits, these deviations accumulate and can put the spacecraft in danger in either crashing with other satellites or re-entering the atmosphere and burning up. As the number of satellites in orbit continues to increase, it is critical to develop and improve techniques for mitigating the effects of orbital perturbations, making sure that satellites don't fall out of the sky.